Given that switches and routers have different trade-offs and different benefits and costs, as you can imagine, some good patterns have emerged for how to use them. In a traditional data center, where you have a bunch of servers serving a bunch of clients with a bunch of data, typically you'll have server machines organized into a rack. And in this server rack, there will be a top-of-rack switch to deliver frames to the right server in that rack. That switch itself is typically connected to another switch that is connected to different stacks. The switch that connects those other switches is called a Tier 2 switch. And then maybe there's also a Tier 1 switch, and above that, there is some router that got you into this set of switches. So you can see our switches are arranged in a tree layer here. We have a load balancer here that is some set of machines that work in concert with the router, so they need to be on the same LAN as that router to communicate with it and help that router pick different servers that different kinds of things should be delivered to. And then you can repeat this whole tree multiple times for different services, say, that have different kinds of data, and then you will have some router that sends packets for different kinds of services onto the right direction to those other routers, and so on. So this is a traditional way of making a bunch of servers work as a unified service to the internet. Many modern data centers are a little bit different in that there's more communication between these servers, and so you don't want to have to go all the way up the tree and then back down to make that communication. It's a question of shared storage and more direct communication. So you need more of a graph and less of a tree, and that has different trade-offs. But this traditional organization is still appropriate for many kinds of applications.